Example 5. Use vectors to solve navigation problems. Aviation. Airplane is flying with an airspeed of 475 miles per hour on a heading of 70 degrees. If an 80-mile-an-hour wind is blowing from a true heading of 120 degrees, determine the velocity and direction of the plane relative to the ground. Okay, so let's draw this out and get an idea of what's going on. I'm going to draw this on, let's put this on an XY coordinate. And not only do we know that this is our y-axis and this is our x-axis, but we've also learned that we have north here, east here, south here, and west. Now, why do I put these north, east, south, and west on there? Because it says here heading of 70 degrees. Now, what heading means is you're starting from the north. So we are graphing this vector beginning in the north and heading 70 degrees clockwise, or said another way, towards east. So there would be 0 degrees, but this is 70 degrees. So it's something like this. It's heading on this, heading this way, okay? So in this representation, this is 70 degrees, or if you prefer, 70 degrees. That reason for the 0 is just to tell you we're talking about on a system of 360 degrees starting from the north. So there we have that, and we also are told that we travel 475 miles per hour. And let's see, does it say how many hours we've been flying? Maybe. Yeah, it doesn't say that. So we just leave that as 475. So that's the speed there. Now the wind is blowing, it says from a true heading. Now this is very important that we catch this, from a true heading. So that's where the wind's coming from, of 120 degrees. So instead of it pointing to 120, it's coming from 120. So how will this work? What we'll do is when we draw this vector, we're going to flip it around. So if it were just simply 120 degrees, we would start at the north, and 120 would be 30 degrees past 90 this way. And we would draw it like this. But in this situation, it says it's from a true heading. Again, what does from mean? It means instead of it pointing to that way, it's coming from that direction. So we actually need to flip this arrow around. So instead of it going 120 degrees that way, it's actually going this way. All right, so let me point this here. If this were 120 degrees, we're now going this way. And so the way to figure out how many degrees is these two would make a straight line. So if it was 120 from the north, then that would mean from north this direction would make a straight line. So what is 120, or rather 180 minus 120? It is 60 degrees. And so that would be what needs to go here. Let me erase this little dot I have. So this right here is 60 degrees from the north to the west. So there's our two vectors. Now it says determine the velocity and direction of the plane relative to the ground. So if I wanted to figure that out, what I would do is I would write these tip to tail. Now I need to also put on here, this is 80 miles an hour. So this is going to be a lot shorter. If that's 475, this needs to be 80. So I'm going to add that as well to my picture here. That represents 80. So how would we do this? We would add tip to tail. So I'm going to take this line, I'm going to clone it, and what I would do is I would add this tip to tail, because that's the way you always do it, tip to tail. And now I have a new vector. Starting from the beginning, this is where I started off from, and this is where I would end. So we now have this representation. I'll move the 475 to this side. I have an 80 here, and we now have our vectors. Now it's very important that we list these in this direction for when we solve mathematically. The easiest way of doing this would be using the calculator and the bracket system. So the calculator over here has these brackets. If you press Control parentheses, that will work for finding these values, for adding vectors together. So we have two vectors at work. We have the purple one, which the purple has a hypotenuse of 475. So if you're going to include the hypotenuse in this bracket system, you need to tell it also the angle. So just as a reminder, when we do this system, you can put in the calculator as an x and a y, or you can put it in as an h with an angle, and this type of with these symbols. And now we would include the angle. Now here's the deal. With the calculator, you always go from the x-axis. So remember this purple line was 70 degrees from the north? You would then have to ask yourself, well, from the x-axis, how many degrees is it this way? Well, if that is 70, then, and there's 90 in here, what you do is you'd say that's 90 degrees minus 70 degrees, which gives us 20 degrees. So this would be my first angle there. So that's one vector. Now what we do is we would add it to the second vector. So what's the second vector? Well, it's this one over here in green that we added tip to tail, or you can look at it this way. Again, what you do is you take the hypotenuse, which is 80, and then we include the angle. Now the angle is 60 degrees from the north, or from the x-axis, it would be 60 plus 90. So you take your 90, you add the 60 to it. We find out from the east it is 150 degrees. Now I could add those in the calculator, and this would give me my exact direction that the plane is heading. Let's go over the calculator and try it. So I do Control and then the parenthesis button, so it gives me these brackets. We were traveling 475 miles per hour, which, let's do that again, 475, you do comma. The angle button is here with the book, so you hit that. And the first angle we found out was 20 degrees. Now I'm going to take that, and I'm going to add that value to this next vector. And so I press Control, parenthesis, to give me the bracket, and it's traveling 80 miles an hour, and it's doing so on an angle of 150 degrees from the x-axis, that is. So I type that in. Now, if I've done this correctly, both my values should be positive because it's a first quadrant vector. And you see that it is. It says it's going 377 miles per hour to the right, followed by 202.5 miles up or north. So there's the value there. And so we could write as our answer is x and y velocity. It says determine the velocity and direction of the plane relative to the ground. As an x and y, this would be my answer. This is, again, as now an x and y. It would be 377 point, I'm just going to go to the nearest tenth, 0.1, and then over here, for the y value, it would be 202.5. Now, if we wanted to know this direct value, we need to change this to an h and an angle. So let's go back to our calculator. Now, to change this from x and y to an h and angle is called converting it to polar. Polar we'll learn about more in detail later in the year, but for now, we'll just go, I'll teach you in the calculator. You press the menu, and down here, you see where it says matrix and vectors. Vectors is what we want to deal with. Down at the very bottom of this list, you'll see vector again. When you click convert to polar, that changes an x and y to an h and angle. Right now, we're in rectangular form. That's what the calculator automatically gives you. That's x and y, a rectangle. But we want to be in polar. So I'll click convert to polar. And when I press enter, it changes the x and y and finds the hypotenuse. Basically, it does the Pythagorean theorem here for the x and the y to give us our h. And then it finds the angle. So we find out that this here would state that the plane is traveling 427. Well, when we round this, it would be 428 miles per hour. Is how fast it's actually moving. And this is 28 degrees from the x-axis, but to get it into a heading, we would actually need to change it from the north. So from the north, if this is 28 degrees this way, then to find this angle here, what we would do is we would say 90 minus the 28.2 degrees from the calculator. And what do we end up with? We would end up with 61.8 degrees. So it would be 61 from the north, and so we're not confused. I'll say north 61.8 degrees towards the east. What the calculator gave us, this value, is east 28.2 degrees towards the north. That's what that value is right there, but we want it this way. This would be our answer here. Now, I know that's kind of a lot of work, and I'm going through slowly. We will be able to do this a lot faster in the future, just because we're going to type this in the calculator, get the value, and convert it right away, and you'll have your answer there without having to go through all of this mess. But I just did this the first time a little slower to give you understanding. So go ahead, and I would recommend you try this one, draw it all out, use your calculator to convert, solve.